Hey guys, welcome back. In the last lesson, we saw how to replicate the Flume events from one source into more than one sink or destinations. In this lesson, we are going to see a commonly used strategy called multiplexing and how to chain multiple Flume events and also how to consolidate Flume events from different Flume agents. Assume you have an application which is running on two data centers, one in New York and one in Chicago, and you would like to consolidate the log messages coming from New York and Chicago into a third data center in Houston. But at the same time, in Houston, you would like to identify and store the messages coming from New York data center in a different location and messages coming from Chicago data center in a different location. This use case is an advanced and an interesting use case and require multiple Flume agents. Take a look at the first Flume agent and it runs in the New York data center. The source here is very simple as it is listening to a log. But what is this interceptor? We would like to push these messages to our Houston data center, and not only that, we would like to store messages coming from New York and Chicago in different locations. So at the destination, we would like to know where each message is coming from. The job of the interceptor is to intercept each Flume event and attach a piece of information which can be later used to identify where the message is coming from. It will be very clear when we look at the configuration file. Now let's talk about the sink here. In our past example, we mentioned the sink type as HDFS, but we stored the Flume event into a file in HDFS. But this use case is different. We are trying to send messages to another Flume agent which is running in another data center in Houston. So we need a different type of sink. We will be using the Avro sink type. Avro sink is used to relay the Flume event to a Flume agent running in Houston, or simply in any other server. We'll configure a similar Flume agent in Chicago. The interceptor in Chicago will tag the Flume event to identify that the event is originating from Chicago. So when the event is sent to Houston, it can be stored separately from the events coming from New York. And again, the sink type here is Avro. Let's now look at the Flume agent in Houston. This Flume agent is interesting because the source for this Flume agent is configured as Avro source, and it is receiving events from New York and Chicago. Something very interesting happens here. We will be using a mechanism called multiplexing to look up each event, and if the event is coming from New York, it will go to the New York channel. And if the event is coming from Chicago, it will be sent to the Chicago channel. Finally, we'll have two sinks, one for each channel, storing the events in HDFS in separate locations. I know it feels like a lot, but when we look at the configuration files for each agent, things will fall in place. And I'll walk you through each and every step. You're in good hands, okay? All the configuration file for this project is in our cluster in location HRW workshop Flume Consolidate. Let's first look at the configuration file for the Flume agent in New York. Let's first name the source, sink, and the channel for this Flume agent. The name of our source is tail source. The name of our sink is Avro Sink New York, and the name of the channel is memory channel. Let's talk about the channel first. We are going to define a memory channel, which we are already familiar with, but let's see two more additional parameters. Agent channels.memory channel, which is the name of the channel, .capacity dictates the maximum number of events stored in the channel. We are going to say 1000. So this means at any given time, the maximum number of events that can be stored in the channel is 1000. If your source is generating a lot of events, you would need to have a bigger number here. The next property, which is the transaction capacity, dictates the maximum number of events the channel will take from a source or give to a sink per transaction. We are going to say 100 for this property. Next, our source. It's very simple. It is exactly the same as the other sources we have seen so far. We're going to tail the log from our sample script application. The following 4 lines are interesting. This is where we are defining the interceptor for the source. This interceptor is going to intercept every event coming out of the source, and it's going to attach a static value to identify that this event is coming from New York. First, give a name to the interceptor. We are naming the interceptor server-loc, short for location. So you will say agent.sources and then the name of the source, which is tail-source, and .interceptors equals server-loc. Next, we have to define the type of the interceptor. So we will say agent sources tail source dot interceptors dot server dash loc, which is the name of the interceptor, dot type. The type is static because we are going to assign a static key value pair. The key is going to be location and the value will be New York. Now, all the events from this agent will be assigned a key value pair with key as location and value as New York. This small piece of information will be added to the header of each and every Flume event. Finally, this source is configured with channel memory-channel. Now to the sync. The type of our sync is Avro because we need our events to be shipped to another Flume agent running in another server, that is in Houston. You need two more properties, the hostname and port. So here we specify the hostname and port where the Flume agent in Houston is running. That is it. Our Flume agent in New York is fully configured. And finally, let's configure the sync to the channel. This Avro sync is going to point to our memory channel. That is it. Our Flume agent in New York is fully configured. Now let's look at the configuration file in Chicago. The configuration file for Chicago looks exactly the same as New York configuration with one slight difference. Look at this key value pair in the interceptor. Here, the value says Chicago. So all the Flume events coming out of this source will be tagged as Chicago. The rest of the configuration is pretty much the same. Now, let's look at the configuration of the third Flume agent that is in Houston, where we consolidate the events from both New York and Chicago. As usual, let's define the source, sync, and channels. We're going to name the source avro-collection-source. We will have two syncs, one for New York and one for Chicago, and we'll name it HDFS Sync New York and HDFS Sync Chicago. We need two channels because the events from New York will go to the New York sync and events from Chicago will go to the Chicago sync. So we'll name the channels Memory Channel New York and Memory Channel Chicago. Let's go back to the slide. We have an Avro sync here in New York and we have an Avro sync here in Chicago. And both are pointing to the source in Houston. So we need an Avro source in Houston. The type for the source is Avro, and we have to give the host name of the server in Houston for the bind property. This is the same location which the syncs from New York and Chicago are pointing to. Next, we have to configure the channels for this source. The source should send the Flume events to either to the New York channel or to the Chicago channel. So we'll specify both the channels here. Now to the important task. How do we know the Flume event is coming from New York or Chicago? And once known, how do we send those events to the appropriate channel? That is the job of the selector. The selector type is called multiplexing. This selector is used when you have to apply selection logic to move the events to the appropriate channel. We're going to use the key value pair with location as the key in the event header to perform the event selection. Remember, the location is set to New York for events from New York and location is set to Chicago for events from Chicago. Now we configure the selector to check the location, and now it is very simple to map the events. You'll simply say agent sources Avro collection source selector mapping.New York, that is, events coming from New York will go to the memory channel New York, and selector mapping Chicago, that is, events coming from Chicago will go to memory channel Chicago. Now that we have configured the channel, let's look at the sync, and it is straightforward. We have two HDFS syncs, one for New York connected to the New York channel and one for Chicago connected to the Chicago channel. The New York sync is configured to write the events in the New York directory, and the Chicago sync is configured to write the events in the Chicago directory in HDFS. That is it. We have now configured all three Flume agents. To summarize, we have one Flume agent in New York and one in Chicago. Both these agents have interceptor to tag the Flume events to indicate the location by adding a key value pair to the event header. The Flume events from these two locations will be pushed to the third Flume agent in Houston using Avro sync, and the agent in Houston will consume these events using an Avro source. The third Flume agent in Houston will have a selector of type multiplexing to map the events to the appropriate channels. Finally, events from New York will end up in New York location in HDFS, and events from Chicago will end up in Chicago location in HDFS. All right, it is now time to see all this in action. We have a three-node cluster, so we are going to assume slave 1 as New York, slave 2 as Chicago, and master as Houston. You only have access to one node, so you cannot try this use case in our cluster. Let's first go ahead and start the agent in Houston, that is in our master node. Let's open the README file, and here's the command to start the Flume agent in master. Let's copy this. Now let's go to the master node. Let's start it. As you can see here, this Flume agent created two channels, memory channel New York and memory channel Chicago. It has also created an instance for the source, which is Avro collection source. Next, it created two instances of sync, one HDFS sync Chicago and the other one HDFS sync New York. And the source, the channels, and the sync are started right here. You can also see the Avro source has a bind address and the port. And this is the address and the port on this master node. Both slave 1 and slave 2, that is our New York node and Chicago node, will be pointing to this bind address. Now it is time to start the Flume agent on slave 1, that is New York. But before we do that, let's start our sample application file, which is going to write log messages. But this time our log messages is going to be slightly different. To identify events coming from New York and to identify events coming from Chicago, on slave 1, that is our server from New York, will write the log messages indicating it is coming from New York. Similarly, slave 2, or our server in Chicago, will write the log messages indicating that it is coming from Chicago. Now let's go ahead and start the sample application on slave 1. I'm going to say / write to file sh. Okay, now our sample application is started. Let's go ahead and kick off the Flume agent on slave 1. Let me go to the appropriate directory, which is going to be New York. Open the README file, and here's the command to start the Flume agent on slave 1, aka New York. Let's copy this command to start the Flume agent on slave 1. Go to slave 1, paste, enter. And here you go. The source, the sync, and the channel are first created, and all three source, sync, and channels are started. And as you can see, the AvroSync New York is configured to connect to the host, which is the master. Before we start the Flume agent on slave 2, let's go ahead and check the master. And as you can see here, as soon as we started the Flume agent on slave 1, you see the sync from slave 1 is now connected to the source in the master. You see the connected message here shows an IP address, which is nothing but the IP address of slave 1. You can check that out here, 172.314.5217. And there you go, exactly the same IP address, 172.314.5217. And you can also notice here the Flume events coming from New York are being written into the New York directory, just as we configured. Now let's go ahead and first start the sample application on slave 2. There you go, the application is now started. Now let's go ahead to kick off the Flume agent on slave 2, or in other words, in Chicago. All right, let's go to the Chicago folder, open up the README file, copy the command, and move on to slave 2, paste it, enter. As usual, the source, the channels, and the sync are started. The sync is connected to the master, which is 172.31.45.216. Now, if you go back to the master, you will see that slave 2 is now connected to the master with an IP address 172.314.6.124. Just to confirm, 172.314.6.124. So now both slave 1 and slave 2 are connected to the master. You can also notice here that Flume events from Chicago have started coming in, and they are being returned to HDFS. That is it. We have configured all three Flume agents, and all three Flume agents are currently running. Now, what we would like to verify is the Flume events coming from New York ended up in the New York location in HDFS, and the Flume events coming from Chicago ended up in Chicago location in HDFS. And it is super simple to verify. Let's first do an HDFS listing on the Flume Avro location. And here we expect to see two folders, one for Chicago and one for New York. And we see both of them here. And let's go ahead and do a listing on the New York location. And here you go. We have several files here under the New York location. Let's open up a file. Hadoop fscat, copy a file, and then open. The file is being written in Avro format, so it's not going to be fully human readable. And it is very easy to see the messages have New York in them, which means the Flume events that are written in this directory are directly coming from our New York node, or in other words, slave 1. Okay, let's now go ahead and look at the Chicago location. Same story here. We have several files created under the Chicago folder. So let's go ahead and open one of the files. I'm going to do fscat. I'm going to pick a file and open it. And it's very easy to see the messages are clearly tagged as Chicago, which means these messages are coming from the slave 2 node, or in other words, from our Chicago data center. That is it, guys. So to summarize, in this lesson, we saw a commonly used strategy called multiplexing. And we also saw how to chain multiple Flume agents and how to consolidate Flume events coming from different Flume agents as well. In the next lesson, we're going to take our Flume learning to another advanced step. We're going to write a custom source to stream live events from Twitter using Flume. And it is going to be an interesting use case. So bye for now. See you in the next lesson.